All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was our Q learning, and tonight we're going to build on top of that. But the big picture idea of this entire formula is to say that every time we experience some new reward, we take that into account, we update our estimate of how good is this action. And then in the future, we can make decisions based on that algorithm. Once we have some good estimate for every state and every action, what the value is of taking that action, and then we could do something like implement a greedy decision-making policy that if we are in a state and we want to know what action should we take in that state, we'll consider for all of our possible actions, what is the value of Q S of A? What is our estimated value of taking that action in that state? And we would just pick the action that has the highest value after we evaluate that expression. So we pick the action that has the highest value, and based on that, that tells us what action we should take. At any given state that we are in, we could just greedily say across all of our actions, this action will give us the highest expected value, and so we'll go ahead and choose that action as the action we take as well. And this is the greedy decision making. When in state S, choose action A with the highest QS of A. But there's a downside to this kind of approach. And the downside comes up in a situation like this, where we know that there's some solution that gets us to the reward, and our agent has been able to figure that out. So if you recall this model that we did earlier on, where our agent had to get to the goal by avoiding the R's or the traps here or the punishments. But it might not necessarily be the best way or the fastest way. If the agent is allowed to explore a little bit more, it might find that it can get the reward faster by taking some other route instead. And maybe we would like for the agent to figure that out as well. But if the agent always takes the action that it knows to be the best, when it gets to a particularly good square that is a better option that it could take, it wouldn't know because it has never tried it. It has learned to take the route that it knows will lead to the reward. It is never going to explore any other possible routes once it has learned the successful route. So in reinforcement learning, there is this tension between exploration and exploitation. We're gonna leave it there for the night. We did do a lot more. We did take a lot more notes, but I'm not gonna dive too deep because I don't want to lose you in translation. And I will keep you posted every step of the way as we pick it up tomorrow. But yeah, for now, this is the Python Poppy, and you guys stay Gucci.